Swayam Prabha. Digital India. Educated India.
Dear students, we are in the module 3 of the course Fire Safety in Buildings. This is an advanced course for the students of architecture and maybe civil engineers, and in the first two modules we have discussed mostly on the definitions part and also our building materials which we use for conventional materials which we regularly use, and also some other materials which are alternative materials which are coming into our building scenario, and what are the ways we can protect them. Coming to today's discussion, we have passive fire protection, mandates from the codes and standards for general buildings and for high rises. For high rises per se, we talk about refuge areas, fire lifts, control of fire spread, etc. So, for every aspect, for every control, one is the passive which is inbuilt within the system. Other is the active which may be additional systems which become active, which take an active role while the situation is happening. So, the passive system is actually embedded and we need not think, but we do it to control fire whenever even if there is no active system, the passive system itself is foolproof to control the spread. Active is embedding a system within the existing one to be only charged or started or ignited in case of a fire. So, those are like fire alarms, like suppression systems, like the fire sprinkler, etc. So, we will today discuss or today we will limit ourselves to passive fire control. This method attempts to control or slow the spread of fire, and for which we may use fire resistant walls, floors, fire resistant barriers like walls, floors, glass, doors, which not requiring operation by people or any automatic control, but they stand as it is with the building, within the building, and create its control mechanism, creates the control of the fire spreading from one to other. For pre flashover fires, that means, if you remember the flashover, those who have not come, flashover fire happens like this. So, this is the flashover zone when within a certain, this is the time and this is the temperature. Within a very short period of time, there is a very increase height which is the flashover. So, this is the pre flashover period. So, if you can actually control a material, a fire, pre flashover fire, passive control includes selection of suitable materials for building construction and interior linings, as we had discussed in the previous module, that do not support rapid flame spread or smoke production or growth of fire. So, we had discussed about gypsum, we had discussed about vermiculite coatings, perlite coatings, we have talked about asbestos boards. So, we can have a lining of such materials which can help in passive control of fires. In post flashover, that means after the flashover has happened and it is the ignition happening before the decay, during this period, if it is a post flashover fire, passive controls is provided by the structure and the assemblies, as we had learnt in our previous module that the load bearing capacity should be sufficient, so that it can resist against any post flashover fire or any failure. It should resist any failure which is coming out of high temperature, that is beyond 800 degree centigrade. Now, we can have fire resistance rated walls. Yes, brick is there, concrete is there, precast structures are there, which we have already learnt, but we can also have glass as a fire resistant rated wall. Glass windows, glass doors, you can see in this picture, these are glass walls, glass facades, assemblage, where you can see these are the metal parts, and here there are glass layers, and these glasses are maintaining the compartment, that means the space where there is a fire, it is not allowing the fire to move from one compartment to the other. Fire resistant rated glass windows, doors having multi-layered intumescent technologies, that means the layer of the glass is having some intumescent paint. Fire resistant rated floors, you can see here there is a picture of a wired glass, that means impregnated with wired glass. These all come under the passive fire control. This glass you will see in a fired door, a small portion which with the steel small mesh inside the glass, it is protecting the fire from movement from one side to the other, also ensuring visibility, because it is put in a door which is a fired door, usually put in a fire escape staircase, so that one can see what is from one end to the other, what is the condition on the other side. So, this has a transparency as well as it has a fire rating. It does not allow fire through it. Occupancy separator, barriers that segregate the two parts of the building, as we talk about walls. Now comes the second point, closures and fire stops. So, we keep on talking, we can talk endlessly with walls, doors, windows, but there are various openings within a building other than these. We need to stop them with fire stops or sealing with fire stop sealants, like electrical routes, like water pipes, like outlet water pipes. They are always within a building, running between two floors, between two compartments, and we never think of them that they can, the gaps through which they are passing can be carriers of fire or smoke. Very importantly, we have air conditioning systems nowadays, and many cases of hospital fires or buildings like hotels fires, the fire, rather than the fire, the smoke moves through the ducts. So, our point is, we must also have, when we create a compartment, when we create a zone telling this is fire safe, this is another fire safe zone, this is one fire safe zone, all openings or ducts or through and through movements of services should be closed down by some way or the other. Let us look into that. Fireproof cladding. You can protect a material with a cladding material or a covering material or a coating material. So, this is the coating material where the main material is here. You are coating it with an intumescent calcium silicate, gypsum board, epoxy, cellulose fiber reinforced concrete, whatever, to make it fire safe from one compartment to the other. Compartment means one space to the other. You can also have fireproof cladding, where you can see the details. Here there is an insulation and there are some expansion joints through which the fire can pass from one space to the other. So, there are expansion joints through which fire can pass. So, sealing is required in those areas. This cladding is a fireproof one. So, this cladding does not allow the fire to move and burn out the insulation as well as the wall, it does not touch. So, these fire resistive wraps or boxes or tapes made of fireproofing material to protect specialty valves and other items requiring protection against fire are to be embedded within or to be kept within the system. As we had seen this slide previously, buildings having residential use, hotels, educational institutions, business, mercantile, industrial buildings, assembly buildings and all hazardous buildings, we have to take permits from the fire department against certain height norms, certain floor area norms, and we have to create our structures accordingly, according to their recommendations. So, if we have a building which is very large or very long, that means a building, say an institutional building which is say 200 meters long. These kind of buildings will require at every running length of 50 meters, they need something called an expansion gap or expansion joint. What can happen? We usually or generally when we design, we ignore these gaps, but these are gaps through which fire can pass. These are gaps through which smoke can pass, and these are usually 50 millimeter gaps. So, it is 2 inches. In institutional buildings, in assembly buildings, you can even see these gaps. This will also be along the elevation. So, fire smoke can come out through these gaps. So, you need proper sealing of these gaps. You see here mineral wool based sealant, here blanket based sealant means fire barrier, foam based sealant on wall are the caulking compounds, that means you are plugging them with mineral wool or blanket based fiber or foam based material to fire stop such expansion joints. You are either cladding them, that means you are putting a dress or a cover of perlite, vermiculite, calcium silicate, gypsum or intumescent paints. You are plugging all expansion joints with mineral wool, blanket based fire barrier or foam based fire barrier, so that the fire or the smoke cannot move from one space to another. There are mandates for high rise buildings, as we had seen in the list of buildings. As you see, residential buildings more than 15 meters or hotels more than 12 meters. That means, there is a height limit, you have to take permissions from the fire authority. So, they will give you permissions only when you have a refuge area. So, buildings which are more than 24 meters, it is mandatory to have a refuge area. So, if you see this section of the building up to 24 floors means 24 meters means it will have few floors in between, say around 7 to 8 floors, and after which there will be a certain space dedicated for a refuge area. How much is that? 4% of the floor area in case of residential, or 6% of the space if the use is commercial, and that is not coming under the FAR, that is the floor area ratio. So, that comes free. And then when next, again within another 15 meter, that is 24 meter to 39 meter, that means another 5 floors expectedly, you reach to 39th meter, and there you again have this refuge area. And again after 54 meters, you again have this. So, at an increment of 15 meters, you have to provide a space which is called a refuge area. Now, what is that? It has to have an external wall. So, it is a place where people will gather and they will expect or wait for help, because they may not be capable of going down, they may be in a fearful condition, but yes, because they are facing the external, some device or some mechanism from there will help them for the rescue procedure when the fire tender, when the people come for the safety issues. So, if this space is not provided as an architect, if you are missing out this, your plan won't get sanctioned from the fire department. So, what are the important things there should be? It should be area for rescue assistance, there should be an evacuation chair, there should be fire extinguisher, and there should be a communication system. So, usually when in this case of a fire, all electrical systems collapse or they are switched off, so that no further damage happens, but certain emergency lines remain active, of which this fire rescue lift refuge area connection through a staircase becomes mandatory. So, usually refuge areas are collection points very close or within a staircase system, and where from the firemen can actually do some rescue operation. In many buildings, these areas are misused as stored spaces, and in case of fire, the rescue operation gets jeopardized or hampered. So, these are the key points of a refuge area. Now, coming to the fire fighting lift. Now, as you understood that the building heights could go up to 24 meter to 39 meter to 54 meter and then again to 69 meters. Then what next? Because nowadays our cities are getting further high rises. We will talk on them more, and if people keep on walking down the staircase, because we also have a notion in mind that lifts are no longer operational because the power has gone, as I told you. But the concept of fire lift has come in place with the increase in high rise buildings. So, to enable the fire service personnel to reach the upper floors with minimum delay. So, the people have to rush to the top floor for the rescue operation. Yes, they may use the lift for rescue operation also, but the firemen will actually take over the building and they will start their operation from the fire lift. So, the buildings which are coming under the high rises need to have a fire lift, which is usually a 8 passenger capacity lift, or it is a minimum of 8 passenger capacity lift, and the electric supply to that lift is mandatorily separated from the rest of the building. So, it is a very essential service in case of fire or in case of any emergency to a building. So, the fire lift shall be conspicuously displayed in fluorescent paint on the landing doors of each floor, so that people trapped inside inside a building or inside a particular floor, can get a hint that this lift can be availed in case of a fire other than the refuge area. So, the speed of the fire lift also should be such that from the ground level it should not take more than 1 minute to reach the top level, because in today's context buildings within India have gone high to around 300 meters. Our various projects are coming up nowadays up to 300 meters. So, 1 minute time is given. Based on that, the speed of the lift has to be decided considering the height of the building, because you cannot take a very slow lift to take you to the 30th floor or the 60th floor, whatever be the building height, but and say that I got delayed because of it. So, the mandate is, as per the rules or the stipulations, the speed of the lift speed should be such that it should reach you to the topmost floor within 1 minute. Fine. So, this is the fire lift requirement, and if you see this is also adapted from the NBC, you can see this plan which comes with a staircase and a fire lift, and also you see here there is a wet riser hose reel and the fireman talk back. So, the fireman can talk back from here. So, there is a communication system, there is a floor plan of and stairway marked within the and with all the significant displays, and there is a lobby space where from the firefighters can start their operation. So, this is what is a fireman's lift enclosure. Now, coming to buildings which need such system is more than 18 meters height and or 9 meters deep from the main axis. That means, building from the road side is deeper than 9 meters, then you need a firefighting lift. One firefighting lift also is mandatory if the floor area is 900 meters square. So, beyond that you can go for 2 firefighting lifts. Must have a protected dedicated fire rated lobby with protected staircase, as the plan already illustrates. Fire lift must serve all habitable levels, but not connected to the basement. So, the fire lift starts mandatorily from the ground floor level and it does not have any connection with the basement. We will discuss basement later on, because basement again is a totally different area, and it has no connection with any kind of vertical movement. So, basement is something they are not connected. So, this is basement, this is above ground. So, no connection between basement and above ground, particularly for fire lift. Alternate water protected power supply, backup generator, drainage channel, all are to be integrated with this fireman's lift. So, fireman's lift is not necessarily one lift, but it is an enclosure having a lift, having a staircase, having a firefighting system within it, and also communicated with the address system and with the address system and connected with the emergency power supplies. Also, it should have a escape hatch. So, in case the area is flooded with water, because the fire hose has already started, there is huge or abundant of water within the system, you cannot come out. So, the escape hatch can help you to come out from that area, and the persons are saved from fire. So, the mandatory building areas, the heights, the depths, etc., are all available in the NBC. Now, I will illustrate one example. This is also a picture from, this is also a picture of D42, which is a 262 meter height building of Kolkata, and here the architect Hafiz contractor, in his plan, what he has done, he has provided at, you can see in the elevation, you can see some balconies. Also on this side, here there is a balcony, on this level here there is a balcony, on this level here there is a balcony, and also on this side you can see here there is a balcony, you can see some. So, what has happened? The architect has done a very interesting way of putting the refuge area. Because it is a very costly residential apartment, he has put refuge area maintaining privacy or giving privacy to each of the floors in form of a balcony or a terrace, because it is again covered in the third level. So, in between two levels do not have any roof. So, again on the after two levels, at the third level, means first then the fourth level, there is a balcony which is a refuge balcony, which is a refuge area, but termed as a balcony. So, every time by definition it is coming as an open terrace and not coming under the area or the FAR, but every floor by this way has received a refuge balcony, and because each of the floors are very private, they need not mix up with the other building inmates, like in a common refuge area above 5 floors people can come and get accumulated. So, here independently you are standing in a refuge area and waiting for your help or your rescue. So, here the first refuge, as it was already told, the first refuge area is at 24 meters or nearest habitable floor, whichever is higher, and then at every 7th floor or after every 15 meters up to 70 meters. Now, as you see here, D42 is a 262 meter building. What happens after 70 meters? For 70 meters or 24 floors and taller, alternate floors of RCC at mid landings are mandatory for such buildings. As I told you in the previous module, that concrete is considered as a break, as a compartment creator, or a material which separates or zones two areas. So, after 70 floors, after 70 meters or from 70 meters, what happens? You have to put a fire check floor. It is a mandatory 1.8 meter height floor, which cannot be used for other purposes, but will have a ring of water pipes, of a water pipe, which will drench the entire building facade. So, what is happening? The building tower above 70 meter will be drenched by water from this floor, which is the fire check floor. So, water will actually drench the building from here through nozzles along the building, entire periphery of the building, and it will not allow any kind of flame which can come, any kind of flame which can get generated at any floor, it will not pass from this level to upper level. Is that okay? So, that is called a fire check floor, where the drenching system is, or with a pipe the drenching system is put and not allowing the fire to move beyond that level. And then again another level you move up, because it is not a joke of having 262 meters. Burj Khalifa 800 more than plus meters. So, we have so many tall buildings where fire has become a very important part, without which the building cannot, the safety of the building cannot be ensured. So, these also are called, these drenchers are also called wall wetting sprinkler system. So, the water will flood the facade, so that no fire or flame can travel from one level to the next level in the vertical area. So, works by flushing water and stopping fire by spread is, it is also called water curtain system. So, I am exposing you to these terminologies, because we will later see that many buildings have actually experienced this kind of facade fire, which is very dangerous. And this is how, through our controls, our mechanisms or our permits are issued, so that our buildings remain safe, and the building remains safe, and the people inside it also remain safe. To mention, this building also caught fire once, though there was no occupancy at that time, and immediately it could be controlled. Now, let us come to another very important terminology, which is called, which comes under this passive, because passive systems are all embedded systems, all by choice, all already there. You need not bother, the building will remain safe, but active is, you have to start something, you have to start when there is a fire. Now comes the term decoupling. As I have told you, there are various services moving through our building. Without services, a building does not work. Every morning you switch on the light, then only the light works. You open the tap, the water comes. These are all services. You switch on the AC, your building gets ventilated, it gets air conditioned. So, all these are roots which are embedded through the walls or through the gaps or between the slabs or in the false ceiling. So, penetrations, openings other than doors, windows, which we can see, there are several penetrations and openings within a building, and the sealing of these becomes mandatory. You can see here from a side is a pipe sleeve which is there embedded within the reinforcement before the concrete encasing is done. So, through this various other pipes can pass through, maybe it can be water pipe can pass through it, a drainage pipe can pass through it, and when say two pipes are passing through it, there remains the gaps around it. It may be a floor, ready floor, and a pipe is popping up in this direction. So, there may be gap in the periphery, there may be gap in this periphery which needs sealing. So, this is a floor slab in which there is a pipe coming out. This is what is going to happen when this will be built up, when the casting will be done. So, what will happen? These areas will be the portions which can carry some fire or some flame, some smoke. So, to stop that, you have to seal this and seal this lower part, which is called decoupling, means you are breaking the two. How to do? Dampers, collars, mastics, foams, pillows and similar sealings of penetration can be achieved by using this, and the phenomena is called decoupling. I will show you some pictures taken from some free sources. You can see here, when the pipe is there, you can see this black sealant which has been sealing. These are the water supply pipes, this is the drainage pipe. So, between the two floors there remains no gap. So, between two floors there is no gap to carry the fire or the smoke in between, because these materials are also ignitable. See, here there are electrical trays which are again protected with fire resistant materials and also with proper sealing. Here you see some shoe kind of thing has been put to encase this joint. This is another joint, this is a pipe and this is the ceiling, where this kind of silicon boot has been put around, so that no fire can move from one end to the other. But remember, when it is I will come to that slide, but when it is fire moving within this tube or smoke moving within this tube, that happens if the line is free and it can carry, like air conditioning ducts, it can carry smoke instead of air, and it can cause a huge damage, and it has happened. There are several examples of that. We will come to that. Prior to that, I will show you another picture which is a schematic also taken from some free image. This is a garbage chute. Usually for high rise buildings, you have a garbage chute like each of the floor people. It can be in a hospital also, it can be in a hotel also, it can be in a residence also, where the waste is actually passed from various floors which reaches to the ground floor. Like it is a tunnel kind of thing, it is a chute kind of chute, which is a chute which takes the materials to the base. Now, it may be garbage in case of residences, it may be laundry in case of hotels, may be hospital, it may be hospital waste in case of operation theatre of hotels, it may be carriers of various ignitable item, non-ignitable item, but yes, this contains oxygen and this has access to any of the floors. So, there is a door, you can see here there is a hatch door, you can open and put your garbage. So, this is an electronic control. So, you can see wet, dry, so that gets segregated at the base. So, this is you can get a wet waste, you can get a dry waste, they are getting, one can go for recycling. Here there is another energy related some battery related wastes. So, all things segregation can be done. So, depending on whichever you are pressing, that chute becomes accessible and your material flows to the bottom. Now, what are these? Where is the fear? These can be a carrier of fire and smoke. So, in case of fire, all these lockings should be ensured, these should be locked, so that no fire or smoke can come out to any of the floor which is not affected by fire. If it is affected by fire, if it gets affected by fire through an open chute, then the purpose of safety gets lost. Now, as we have talked about that kind of chute which is a garbage chute, we look into what can happen within a air conditioning duct. You see, this is the section of a duct. So, this side is say zone 1, means this side is zone A and this side is zone B. So, on this side is fire, that means some fire has grown and some smoke is getting through the return air. hope you understand return air duct. So, from through the return air, that means the internal stale air or the hot air is getting into that to the back to the system for getting cooled, and the cool air is coming back. So, in case of fire here there are sensors, and you can see here there is a, I am not doing on the picture, there is a compressed curtain. On sensing the temperature rise, this curtain falls and closes, acts as a barrier. So, no more of return air, which is smoke in case of a fire, can enter from zone A to zone B. No. So, these are live areas through which smoke can move from vertically, move horizontally between compartments, and which does not get identified at the first point. So, these kind of detectors, working sensors should be there, which will open a flap and disintegrate the two parts and stop the smoke movement or fire movement from compartment A to compartment B. You can see a picture taken or a photograph where you can see the blinds are or the blades are there, just like louvers, they will close down, and it is a damper or dampening or stopping the movement of smoke or air or any toxic thing from zone A to zone B or zone B to zone A, whatever the situation is. So, there is a thermal sensor, an actuator, and the sleeve holding the whole blades, and this is how within an air conditioning ducting, these are to be kept at intermittent locations, so that smoke does not the spaces does not get contaminated by any kind of toxic gas or smoke or fire from one area or one compartment to the other. Side by side we can see another duct here in this picture, which is a smaller scale and having a grill on top of it. What is that grill doing? That grill is actually painted with intumescent paint and called an intumescent damper. On sensing heat or increase in temperature, those paints will bulge out and lock the entire grill, so that from zone A to zone B no movement of toxic gas, smoke or fire can happen. So, these are to be embedded within when the installation of a system is done, and these are all passive mechanisms. However, this sensors are the active part within it. So, all HVAC ducts mandatorily should have such systems when it is a central air conditioning system within a large scale building. However, kitchen ducts, car parking extracts in basements should not have any damper, because kitchen duct always opens outside. If you are all aware, kitchen ducts are taking the fume or the exhaust thing outside the building, which is important to address that yes, there is a smoke, there is a fire. So, the kitchen ducts needs no dampers. Ducts are connected outside, giving clue or cue to the people that there is a fire that is happening in some level of a kitchen where people can go and take action. Similarly, same for basements. Car parking area extracts in basements, they should all move up and exhaust their release the gases or the smoke outside the building and not to the passing to the upper floors. So, that is why car parking extracts in basements always to throw out the stale gas or the fumes to the external. So, here in this picture also you see all the points through which the duct is passing. So, this is actually the duct through which the kitchen is getting its, see these are mostly for high rise buildings. So, kitchen is getting an external, is getting its exhaust of its kitchen. So, through a duct which is passing through this chamber and leading to a external. So, any fume or any smoke, any fire or any smoke that is generated will pass through it and get exhausted outside the building. So, here you can see a clue that there is a fire. So, here you are not going to put damper. If you are putting damper, your purpose is gone, but you have to put damper within HVAC routes. You are not to put damper in a basement exhaust, which opens finally to the outside. So, if your basement, this is your ground level. So, your basement exhaust should exhaust the air or the toxic gas or the fume outside into the atmosphere. Now, we will discuss this later on also in case of curtain wall, because we are talking about high rise buildings also. We see sometimes the building facade is having only glass and it is a structural wall, there is a structural system, but otherwise entirely it is facade. So, it may happen that this is, you can see here there is a ceiling, which may melt and allow the fire to go up. It can allow the fire to go up. You see here at single glazing breaks at fallout of 400 degree centigrade, 6 millimeter glass, float glass breaks and allows the fire to move up. So, glass has broken, fire has gone up, sealant has broken, fire can go up. Fire can go up from broken glass from one level, hit the wall glass and go up. This is called a leapfrog kind of spread. This is called a chimney spread. So, you are trying to exhaust this fire, but meanwhile, it has actually molten the sealant, and the fire is moving from first floor to the second floor and maybe further to the third floor. So, we have to be, so what has happened? This concrete has given a very nice protection, but because of this curtain wall, this sealant is the weakest part, which has gone molten because of the temperature. Now, what is that sealant? That sealant can be a polymer, it can be a rubber, it is an adhesive, it is a gasket, and it can get molten, whereas the floor may not be damaged. Fine. So, we have to be very cautious when we are talking of buildings of a larger scale, and when we are treating a facade in this kind of manner, the fire can move from any floor to any floor, and that there is the fear, because till now, till our conventional buildings, low height buildings, what was the problem? It was one compartment controlling one compartment, but if it is a facade related fire, it can move to heights, and if it can penetrate into the floor, then it can lead to further damages. So, for passive protection, whatever we had learned so far is very important, but when the building moves to a next scale or a larger scale, we have to also think of active mechanisms, but yes, passive protection can save your building, rescue the whole team out rescue the whole occupants outside the building by proper selection of building materials, embedding proper sealing every joints, decoupling and continuing with the good parts, following the standards, following the fire norms. We can keep our building safe, our regular building safe to the extent to most of the safety points. However, we will also take up active fire system in our later module, where we can see what are the needs for active fire system, because not all things are under control through passive mechanisms because of the scale and the order of the building, and we have to look into the active parts also. So, with this I end this lecture and thank you.